session. So, can you hear me? Everybody's here?
Yes, I can hear you. Thank you.
Okay, thank you. And also here, Nobel is in the venue, and Dr. Sokolov is the other outside of Tashkent. And His Excellency Mr. Kosan is joining this meeting. Thank you so much about that. So I will the session, the building resilience from climate change. So actually, the COVID-19 pandemic has gravely affected the countries all over the world, socially and economically. In the current COVID-19 environment, the immediate attention of the national leaders and the government and the people in the world have been focused on mitigating the COVID-19 infection and treating those who become ill. But however, the threat of the related diseases, as well as climate change impact, remain immediate now as before COVID-19. So many people around the world have been affected, and the thousands of people died due to water-related diseases, which are increasingly frequent with the impact of various global issues such as urbanization and climate change. So,
진행자님, 그쪽 마이크 좀 꺼주시겠어요? 에코 때문에 많이 소리가 이쪽으로 들려요. 네.
yeah, thank you. So the competition and the complications among the disaster risk reduction, emergency responses, and COVID-19 healthcare responses could magnify negative impacts in some countries and cities. Particularly for women and children are the most vulnerable group under water disasters. Especially under the COVID-19 pandemic, we need to pay attention to the most vulnerable group, gender and children. So today, I host four participants, four speakers, Ms. Yunari and Nobel Baliza and Dr. Vadim Sokolov and also His Excellency Mr. Watpokosa. Would you please introduce yourself very briefly before the presentation? From Yunari.
Yes, thank you, Dr. Hong, for inviting me to the conference and as well as your brief explanation about me. I am Yunali. I work in JH Sustain in Korea. This is international development consultant company, and I work as a researcher here. And I studied international development, and my major was looking at the working force, the poverty, and chronic poverty. So that'll be about my introduction. And today, as noted in the information, I will introduce about the climate vulnerability. So I'll see you in a minute.
Thank you, Yuna. So next, the Nobel Baliza. Nobel, can you introduce yourself? Nobel is in the the room in the venue.
Hello, can you hear me?
Yes.
Yes. So my name is Nobel Baliza. I work in ICUH in Incheon. So we are working on a lot of issues related to water, basically. And my personal background is hydrology and hydraulics. And today I will be introducing about some application of the smart water grid concept to Nepal. So yeah, thank you very much.
Thank you, Nobel. So next, can I invite Mr. Watpokosa, His Excellency, Deputy Director of the Cambodian National Mekong Committee.
Good afternoon, everybody. I'm Watpokosa from Cambodia. I work for Cambodia National Mekong Committee as the Deputy Secretary General. Nice to meet you all. So I'm very happy to meet you and to make my presentation contribute to this important conference.
Thank you, Your Excellency. So Now, I'd like to invite Dr. Vadim Sokolov, the director of IFAS. Vadim Sokolov.
Yes, thank you so much. I'm very sorry, I'm not in my office. I'm in the field trip, so I have access only by my phone. And I'm representing International Fund for Healthy Saving, and today I would like to say short story about what Uzbekistan is doing to mitigate the impact of this ecological crisis around RLC.
Thank you, Dr. Vadim Sokolov. It's okay, this, one of the advantages for us, have this kind of webinar meeting. So even you are on the field trip, we can share with you your idea. Thank you very much. Now, I'd like to invite the first speaker, Ms. Yuna Lee, the climate change and the gender issue. Please, you have floor, Ms. Yuna Lee.
Yes, I will share my screen. And
구름 모양 밑에 있어요. 화면 공유.
네, document sharing 눌렀는데 여기서
거기서 한 번 더 위로 올라가실래요? 여기 칸?
하나 더요? 이거요?
네, 그 컴퓨터 모니터 같은 게 화면 공유예요.
네. So are we all seeing the document now? No, not yet.
I cannot see that on screen. Your file.
I'll try it again.
화면 공유를 못 찾으시는 거예요? 찾았다.
된 것 같아요. 보이시나요?
Yeah. Thank you. I can see.
Okay, so yeah, it is my honor to have a presentation today as a first speaker, and thank you for everyone's attention. My topic for today is sorry, to see the vulnerability and vulnerable groups of climate disasters. And this topic is specifically, I think, important because we are facing the discourse of climate justice and climate inequality. And the basis of this is how the vulnerability to climate disasters are dispersed around the world. So I'll start with what is climate vulnerability and the understandings of climate vulnerability in different groups. And the second is vulnerable populations of climate change. And I have women and girls as an example. And third, we would look at the climate inequality and climate justice and how this discourse has been developed based on climate vulnerability. So Intergovernmental Panel of Climate Change, IPCC, had released fifth assessment report in 2014, and the sixth version will come out in next year. And so this is the latest version, and they see vulnerability along with climate and socioeconomic process of the world we're living in. So on the left side, it says climate, and there is a natural variability, which occurs naturally, and there's anthropogenic climate change, which arises from the world that we are living in, how the human beings are acting upon the climate. So when we say climate change on the left side, it's a change of climate which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere, and which is in addition to natural climate variability observed over comparable time periods. So when we say climate change, it naturally includes not only the natural change and variability of the climate, but also the human activity that contributes to the change of the climate. And on the right-hand side, it shows socioeconomic process, and that involves socioeconomic pathways that the human beings have been developed, and the adaptation and mitigation actions that we are doing. And there's a whole governance from international, domestic, and regional governance. And here in this, in this process between climate and socioeconomic process, there is a risk of climate change, and that also includes the relationship between vulnerability, hazards, and exposure. Hazards are how climate disaster and climate change affects negatively or sometimes positively to human beings. And exposure is how we are exposed to climate disasters. And vulnerability, on the other hand, is how we are susceptible to the climate change. And we will look at further down further now. And so how we define climate vulnerability, it has been developed since 1992, I would say. Then there were so many discussions of understanding climate vulnerability, and the first definition from IPCC, their assessment report, second version, came out in 1995, and it says the extent to which climate change may damage or harm a system. And it says it depends on not only on a system sensitivity, but also on its ability to adapt to new climate conditions. And from here, it's sort of a rudimentary and basic understanding of climate vulnerability, and then it developed as the box in the middle, the IPCC assessment report 3 and 4. It says the degree to which a system is susceptible to or unable to cope with adverse effects of climate change, including climate variability and extremes. And this is more narrowed down understanding of climate vulnerability, and they made a function down there. Climate change vulnerability is a function of sensitivity, exposure, and adaptive capacity. And that is the basic and well-known understanding of climate vulnerability. However, but they faced a lot of critics saying that this is residual understanding of vulnerability, although the climate vulnerability and vulnerability in general has to be understood as a context in the context of the social surroundings. So IPCC Assessment Report 5, which came out in 2014, changed their view and changed their definition to the propensity or the predisposition to be adversely affected. And as it says, like, it's more holistic approach to understanding vulnerability, and this is why they have been changed. And as in the middle, the working field for international development has approved and understands the vulnerability as a function for simplicity. But when we are actually looking at the vulnerability and when we deal with the concept, it should be more in a holistic approach, and that is the way we are going. So there are 3 determinants of climate vulnerability as shown in the function above. So I'll start with the exposure on the top. Exposure means that the presence of people, livelihoods, environmental services and resources, infrastructure, or blah, 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 etc., in places that could be adversely affected by physical events and which thereby are subject to potential future harm, loss, or damage from climate change. And adaptive capacity on the right. We understand adaptive capacity as the capability of a system to adjust to climate change, including climate variability and extremes, thus moderation of potential damages, taking advantage of opportunities, or coping with the consequences. And on the left side, it's sensitivity, and it is a degree to which a system is affected, either adversely or beneficially, by climate variability or change. So put these 3 factors together, and this is how we determine climate vulnerability. And this is more of an understanding how we calculate and we understand climate vulnerability with the 3 factors. So on the left side, when you see the exposure and sensitivity, when they are big and adaptive capacity is small, we would have more climate vulnerability. And on the right side, you can see exposure is smaller and sensitivity is smaller. And when we have more adaptive capacity, then we would say we have smaller climate vulnerability. And this is how we generally understand climate vulnerability so far. But there's a, as we saw in the IPCC assessment report 3, 4, and versus assessment report 5, there's a clearly a distinction between how we understand climate vulnerability, and that we would say that is a difference between residual climate vulnerability and contextual climate vulnerability. So on the left side, it shows how we calculate, and as a result, we understand climate vulnerability, and that means it's residual. So we would understand from the top, there's a climate change and how much it is exposed and how it responds, and we calculate them, and there's the answer as a climate vulnerability, and that's how we understand climate vulnerability as a residual. On the other hand, on the right side, it's contextual. So it's not an answer from a function, but it aligns with all the other socio-political and other political institutional structure and all the other factors that affect climate vulnerability. So it's not a straightforward answer from a function, but it's more in the context of the society. So this is how we understand vulnerability in many different academics, and there's a disparity between the two. And when we are discussing climate vulnerability, I think it's important that when the speaker says the climate vulnerability, we need to understand which of the residual or contextual climate vulnerability he's referring to. And I think when as a researcher, and I work as a project manager now, and there is a definite gap between these understandings. So I think it is important that we point this out, that there is a difference. And when we look at the contextual climate vulnerability, this was in the 5th assessment report of the IPCC, and it's more elaborated in the graph. So you can see the dimensions of inequality that exist in the society, that it comes intersection, and then there's a population with inequality. And when we meet climate change, then it would again goes out to low to high vulnerability, depending on how much capacity and opportunities for you to respond to it. So I'll just briefly go over. And yes, so this is more of the socioeconomic understanding of climate vulnerability, and there are the many factors, and I made it into 4 categories. And the first one is not showing clearly, but it's access to assets, and that depends on which race you're from, caste, gender, and whether you are in poverty or not, and disparity in socio-political power that you have. And this would determine how much access you have to the assets compared to when you're facing climate change. And the second is governance. So public-private governance and civil society participation, and these kind of decision-making process also affects our vulnerability to the climate. And third one is culture, and there is a tangible and intangible factors of cultures, and there's a perceived risks and quality of life that you are having. So these kind of things also affect how vulnerable we are to the climate. And the fourth one is knowledge information, and it includes transmission of environmental knowledge and social memory, such as the younger generation wouldn't really recall the major cyclones or typhoons, and that kind of social memory goes away as the time goes. So it's important that we keep those memories and we learn from the past. And third one is traditional ecological knowledge, and this is also very important because we are losing them. And fourth one is geographical knowledge, and fifth is knowledge co-production. So co-production means that with different kind of knowledge, we have to understand climate as a whole. So all these kind of things affect how socioeconomic climate vulnerability is formed. So this is how we understand vulnerability as a changeable status rather than a residue and a answer of a function. So going to the second part, there's a vulnerable population of climate change, and like within maybe over a decade, the world has strived to map climate vulnerability, and it showed vulnerable regions and populations. And funny enough, we had this almost exactly the same map with the existing social inequality map and the climate change vulnerable map. So it shows that climate change exacerbates existing social inequality and vulnerability. And underneath are underneath the boxes are the vulnerable people. And I would like to focus on women and girls today. So here it shows very briefly, although it is important that we don't really have sex aggregated data, but with the limited data we have, we calculated, and it shows that women and girls, children, are 14 times higher, 14 times more likely to die when disaster occurs, and that is a, I think, striking number. And the next, the 70% is that in 2004, 70% of the death toll from tsunami in Asia was women. That is in 1 year, and it's again very striking number to compare with the men and women. And the next in the middle is 30%. It says it's the cyclone Gorky that hit Bangladesh, and it was one of the biggest cyclone that hit Bangladesh in the history, and that recorded 140,000 casualties. People died, and 30% was women who were older than 40s. And when you think of the whole population, and normally it should have been less than 10 or something when we are just having the age groups and gender, but there is certainly a disparity between women, especially in the older age. And the last one is 87%. It says that in 2008, Cyclone Nargis hit Myanmar, and 87% are married, and 100% of married women lost their main source of livelihoods. So funny, it's unfortunate, but climate disaster affects more on women, not only their lives, taking their lives, but also to the places where they rely on their livelihoods. So these are small numbers that we can look why women are more vulnerable. And there are many factors why women are more vulnerable, but I guess it's, yeah, because of time, I will just skip to the next. So the third part is climate inequality and climate justice. And here I just wrote it down as a question, a sentence that says climate change is an environmental justice issue for 3 reasons. So I'll start with the number 1, and it says there are causes of climate change. Social inequalities drive over consumption, a key source of unsustainable levels of greenhouse gas emissions. So historically, like over nearly 200 years, Western and developed countries have been developed, and they've, well, emitted a lot of greenhouse gases. But unfortunately, the consequences are shown in the less developed country or the developing country. So there is an inequality, and we call it a justice issue. That's number 1. And second is that the impact of climate change are unequally felt by the rich and poor, and disparate impacts will continue to increase in future generations. So not just only countries per countries comparison, but also within the regions, poor people are more likely to have adverse effect from climate change. And that also includes the generation gap. So it's not only horizontal, but it's also very vertical inequality that we are facing. So that's the second. And third is policies designed to manage climate change have starkly unequal consequences, and the process by which emissions reductions and climate adaptation policies are decided tend to exclude the poor and the powerless. And it has been always the case in the history. The political power has always been within a certain group of people, and that also affects climate change and how we respond to it. So that's the third reason why environmental climate change is an environmental justice issue. And as we are going forward to climate justice, I'm sorry. I think it is important that we first look at the climate vulnerability, because it's where we started to notice that there is a climate inequality and climate injustice. So these are the way forward for a better future for climate justice. And I think I'll just finish here. And any questions?
Wow, thank you so much, Yuna. So it was great. So actually, I think it's much better to have a question and answers and then comments about your presentation after all the speeches. So then I'd like to invite. It was great presentation, Yuna Lee. Thank you so much about that. I really appreciate your very excellent presentation. From the gender aspect. And then now I'd like to invite Mr. Nobel Baliza. So Nobel, you have the floor.
Can you see my screen now? Can you see the presentation or?
It's not showing on the screen. The camera is just.
화면이 안 보이시나요?
카메라 화면을 찍지 말고 스크린샷을 해주세요.
저 스크린 쉐어인데.
왜 조그맣게밖에 안 보이죠, 그러면은?
혹시
됐습니다. Yes, we go ahead.
Yes.
Baliza.
Hello, so I will be presenting the application of the smart water grid technology to Nepal. Yes, so that's the summary of the presentation. So as yeah.
더 올려요? 네.
여기 밑에 부분 잘 안 보여서.
더 밑으로 내려가요.
Okay, so to start with a brief introduction. To start with a brief introduction and some concepts. Yeah. So we know that the 21st century brought some new challenges as a consequence of mainly population growth and global warming. So we have less economically developed countries which are facing a serious threat of water scarcity, and that's due to a combination of factors. So that can be aging infrastructure, ICT gap, lack of investment, institutional constraints, poor data, and all of this together most of the time. So the smart water management definition, as it was given by IWRA and K-Water in Korea, it's the use of ICT, so information and communication technologies, to provide real-time automated data for use in resolving water challenges through IWRM, so integrated water resource management. And the smart water grid is the key structure for the application of this smart water management paradigm as an architecture which combines sensors, monitors, GIS, satellite mapping, and other data sharing tools. So yeah, the five big concepts which are under the smart water grid denomination, you've got five modules basically. So one of them is a real-time water balance assessment, so to understand how much available water do you have and how much water resource is needed in real time. Then you have an advanced metering infrastructure, some smart metering devices for leakage detection and WTS management, an integrated water distribution system, and some module for water quality improvement by blending technology, which we will be introducing a little bit later. So the Korean experience with smart water management, we've got the two main systems, so the multi-regional systems, which are managed by K-Water, which is the national water company of Korea, and which ensure approximately 50% of the total water supply. And then we've got the local systems, which is a total of approximately 161 local governments, which are in charge of the remaining 50% of the supply. So you can see here the Seoul metropolitan area water supply. So it's a very big area, as you can see. It supplies water the system supplies water to 28 local governments with a number of customers, which is of approximately 10 million. So you can see it's a very big system. And the capacity of the system is 8.5 billion cubic meters per day, which represents 50% of the total supply which K-Water is providing and 25% of the total water supply of the country. So it's a very big system, and the work scopes of this system, there are two main work scopes and 6 modules. So the main work scopes are water supply control and water quality monitoring, and inside of this you've got real-time network monitoring, demand forecasting, pump scheduling and control, network modeling and analysis, GIS-based facility management, and alarm and leak detection. So this system, the Seoul metropolitan area system, it's also characterized by a very long length of pipe. So the total pipe network is more than 1,000 kilometers. And among these 1,000 kilometers, you've got only a little bit more than 200 kilometers, which are single water pipes. So what does that mean? That means that 80% of the supply is ensured through dual pipes. So dual pipes, they have been designed so that in case there is a pipe failure, you have another route to provide water, basically. You don't have a single pipe which is providing water, because if you have a single pipe providing water, then if this pipe breaks down for any reason, then it's very difficult to bring the connection back to the area which doesn't have water anymore. And they also have developed this 8-step system in order to detect leakage and to address leakage problems as soon as possible. So the leak occurs in the first step. It's detected in real time thanks to sensors, leak detection sensors. An emergency team is organized. A hydraulic analysis of the model is performed. So the water network supply model it's modeled in real time with the data collected on field. Then through this linked supply that we mentioned earlier, so basically there is always a secondary route to provide water if one pipe is broken, as you see on the picture. So you've got one pipe which has failed, but you still have another route to supply water so that there is no discontinuity of water supply. Then there is a field command vehicle which goes on field with the emergency team. The leak is repaired and the ordinary supply is reinstalled. And among the technologies which have been applied in Korea as well, so we mentioned metering, smart metering. So in this smart metering, we've got 3 data transmission technologies which are involved. So for short-range wired communication, it's the communication which happens between the water meters which are in the houses and in the buildings, and the remote metering unit, which is collecting the data from all these meters which are deployed on field. Then we've got a mid-range wireless type of connection, which occurs between this RMU, which we mentioned earlier, and the data concentration unit, which is a bigger logger. Basically, it's one logger which is placed in a neighborhood, and it collects the data registered by all the buildings and all the houses in the area. And then we've got a long-range wireless network, and this is between the base station and the remote monitoring system. So this is basically at the scale of a big town such as Seoul or Incheon or another town. You've got one centralized center which needs to collect the data from everywhere, and for this you need really long-range wireless type of connection. So this smart metering has been deployed on field in various places in Korea, so that's one example of deployment. So this is a 6-step strategy for deployment. So we do some type of site survey. We look at the existing meters. So most of the time they are not smart meters, they are just meters which have been there, manual meters, and you need to go to take the reading, to register the reading, etc. So we replace these existing meters by smart meters and display units which are installed on field. Then we install a coordinator. So the coordinator is this data logger that we mentioned earlier, which is going to be collecting the data from all the meters which are in the houses. Then there is a need for commissioning. So the commissioning is very important. It's the step where you make sure that when you install your coordinator, actually all the meters that you deployed on field, they are connected, really connected to this coordinator, because sometimes it cannot be the case. Then you proceed to the data acquisition, and then you've got this graphic user interface display for the operation of the software. So the graphic user interface display, as you can see, it looks like this. So it's a map. On the map, it shows you how many smart meters do you have in an area. And it shows you, as you can see, the number of connected households, the water consumption in real time, the cumulative water usage, and the smart meter status, which is very important. As you can see on the graph, basically the green smart meters, they are connected to the network and running. The orange smart meters, they are connected to the network, but there is a problem. There is a reason which makes that they are not currently running and functioning normally. And then the red ones, they are not connected to the system at all. So there is a problem of data coverage or some type of issue with that. So you can see that in real time. So now the case study for the application of this type of technology was the city of Beni in Nepal. So the city of Beni is the capital of the Nyakti district. It's got a population of approximately 33,000 people. It's located at the confluence of 2 rivers, as you can see on the picture, one the Kaligandaki and the other one the Nyakti River. And it has also a characteristic which you know, of course, it's Nepal, so it's located in the Himalayan mountains. And you've got an average altitude for this city of Beni of 900 meters, so it's very, very high, and you've got a lot of mountainous terrain around the city. So some figures about the composition of the town of Beni. So you've got an average family size of 3.9 people per family, and the population growth rate is of approximately 3.6% per year. And the water supply is not continuous at the time. So in summer you get effectively 24 hours of water supply in most of the places, but in winter you've got maybe 12 hours at the best, and then the rest of the day you don't have water supply at all. And also by 2022, we know that the projected demand due to population increase, the projected demand is going to be greater than the existing available supply. So what's the water distribution system in Beni? It's a gravity scheme, basically. So gravity schemes, they use the existing topography for water distribution. So there are no pumps, valves, and devices like that. It's just basically you have the water source, which is located higher than the distribution area. So the water is naturally flowing down from a higher point to a lower point. And you've got 2 main systems, which are the Ritekarka and Koprekola and Dulekola systems. So the Ritekarka is the main source, providing approximately 30 meters per second of water. the second one is secondary sources, and then the Pumti Kola, it was a source which was used before, and it's been abandoned because there is high turbidity in the wet season, so it cannot be used for drinking purposes, basically. And we have also some modeling figures of the Beni area. So this is an EPA Swim software model representation of the area. So you've got three main areas: the Beni Bazar, the Beni campus area, and the Mangal Ghat area. So now, one of the main problems in Nepal is aging infrastructure. So if you have aging infrastructure, that means you have pipes which are very exposed to leakage. So when we look at the non-revenue water rates and figures for Nepal in general, you see that here it's been split by season, but basically there are, in most of the seasons, you've got approximately 40% of non-revenue water. So what does that mean? That means between the water which gets in the system and the water which gets out of the system, 40% of it doesn't bring any benefit, any money to the water provider, because it's been lost through physical losses, basically. So there is leakage in the network, and through this leakage, almost 40% of the water, sometimes during the summer season, for instance, all of this water is lost. So the sources are here, but basically some studies have shown that we could get Nepalese rupee revenue of maybe 12 million Nepalese rupees per year if we were able to apply this smart water grid technology to the city of Beni, for instance. So what is the current situation in Beni? So as I said, mountainous terrain, very steep slopes, and most of the pipelines are located above ground. So what's the problem of pipelines located above ground? If the pipelines are not buried in a mountainous region like that, if there is a landslide, if there are rocks which are falling from the slopes, from the high slopes of a mountain, you can have a lot of pipe damage occurring very fast. So as we see here, you see the picture in the bottom right corner, damaged pipes. And also we don't have protection on the pipe junctions. So the pipe junctions are the parts which are the most vulnerable in the pipe network and more likely to have leakage. So yeah, the conclusion is damaged pipe burst, discontinuous water supply, and water quality issues as well, because you can have substances which are seeping from outside inside the pipe. And also, as you can see, there is no automation. There is no automation at the time. So the water meters, the household water taps, you can see it's aged infrastructure, no automated metering. And the water quality control is the same. There is no automation. It's all done manually. It's written manually on the boards. So what's the problem with this lack of automation? So we have a low data collection frequency. So it's difficult to understand first what's the water demand in real time, to understand the water usage patterns, and also the monitoring of the water quality is not continuous. So basically, if you are measuring the water quality once a day or twice a day, in between you can have pollutants which have entered your water network, but you don't realize that these pollutants have entered your water network until maybe hours have passed, or half a day has passed, or an entire day has passed. And this can create very big problems in terms of water quality and hazard to population. So we listed 3 stages of what we could do in Beni in order to apply this smart water grid technology and improve the situation. So the first stage is focusing on the water intake, the water supply pipeline from the intake to the houses, and the monitoring of this water supply pipeline. The second stage is focusing on the water treatment, and the third stage is focusing on the improvement of the water provision facilities. So now I'm going to introduce a few technologies which exist in Korea, which could be applied in order to improve the situation. So for the water treatment, we've got this mobile water treatment unit, which has been developed as part of the Smart Water Grid project in Korea. So it combines a few technologies, so reverse osmosis, pre-treatment, ozonation, chemical products treatment. All of this is combined in blocks, basically, which can be, they can be combined in the way you need. So what it allows to combine very different sources of water. So it can be surface water, groundwater, rainwater, treated wastewater, brackish water, even seawater. But in the case of Nepal, of course, it's not going to be seawater. But I mean, that means that basically virtually any water that you have as an input, you can find the combination of these unique technologies to put one after another in order to make a water which satisfies the purpose you have in the case study where you're applying it. Then the water shortage assessment tool, this one has also been developed in Korea, so that's been developed for the island of Daejeon-do. Basically, it's been developed because it's very difficult to forecast drought episodes, and that's a problem which occurs also in Nepal. We're gonna see after a little bit after why. Basically, this water shortage assessment tool, it provides a real-time estimation of the water demand and the available water resources, and it anticipates any possible shortage, basically. So it relies on remote data collection, database management, forecasting algorithms, and yeah, this type of technology. And then we talked about the pipes and the problems with the pipes. So one of the solutions, of course, is to replace the portions of the pipes which are above ground by buried pipes. And then we've got this technology which also exists in Korea, which is a three-step maintenance solution for pipes. It's called the smart prevention sheet. So this allows, first of all, it has sensors which are placed on the pipe junction. So as long as there is, as soon as there is a leakage, you're going to get a signal immediately. And also you've got this smart prevention sheet that you can see here, which you put on the pipe, and this avoids, even if there is a leakage, it avoids basically soil or foreign substance to get into the pipe, which prevents water quality problems, basically. For the smart metering and data collection infrastructure, so we've got these LCD display smart meters, which are also being developed in Korea right now. So they are equipped with lithium batteries. They use the low-power wide area communication protocol. They can operate through a wide range of temperature. They send 1 meter reading per hour, so 24 per day, which is quite a good granularity of data in terms of metering. And yeah, they use some type of software and the SQL 2008 database from Microsoft. So there are also other options which are like solar or water power metering devices which can be used for smart metering. Also, in the case of Nepal, the problem is, and it's also been accentuated by the effects of climate change, is that we've got an average yearly rainfall of 1,600 millimeters, so that's quite a lot. But the distribution of the rainfall throughout the year, as you can see here in the graph, it's not constant. Basically, it's not more or less the same rainfall throughout the year. It's a lot of rainfall in the rainy season, so between June and September, let's say, and during the rest of the year, almost no rainfall. So approximately 80% of the yearly rainfall input, it all comes into the rainy season. So it causes floods, it causes a lot of problems. But then during the dry season, there is a big risk of drought because, of course, you have almost no rainfall input. So we can investigate some type of rainwater harvesting technologies as it's been developed here in Manipur. So that's just a tank basically which collects water from the roof. And just to take a small type of example, basically, so we've got, it's almost finished. So we've got this average annual rainfall value. We've got the water demand for a household of 4 members, which is approximately 300 liters per day. So you can see that if it was to be applied even to a very small area like this, you could have quite a lot of households provided with this rainfall harvesting. So yeah, that's it. Basically, the expected benefits: improvement of water supply, improvement of water treatment, real-time monitoring, water assessment tool, and yeah, that's what we could gain from applying the smart water grid technology to Nepal. Thank you.
Thank you very much, Mr. Lisa, for your very comprehensive explanation of smart water grid system and also your case and this later. So now I'd like to invite His Excellency Mr. Wat Bukusar, the Deputy Secretary General of Cambodia National Mekong Committee. So Your Excellency, you have 15 minutes, 5 minutes.
Yes, thank you.
Okay, share your presentation.
Yes. Again, good afternoon, everybody from Cambodia. I would like to share my presentation. You will show my presentation? Dr. Hong.
Actually, you can use the the second box, just under the face, the left side, the top of your left side, the cloud, and below the cloud is you have some face, and then you can see that it's like monitor. So you just click the monitor, then you can show the your screen.
Okay.
Just click the screen.
Moment, please. What am I?
높은 분이시네.
I don't have. So you could not open my presentation there.
And then I'll upload your presentation from my side.
I sent to you.
Yeah, I have yours.
Yeah, but technician.
Okay.
Please try open because I use with another computer, so technician is not here. What the name? About PowerPoint? Yes, okay. Tell me. Back. Back PowerPoint. Cho add one này. Dr. Hong, can
Yes,
you?
the button as well looks like monitor.
Yes, now we client monitor.
Not notepad icon, monitor icon, the left
Monitor.
side.
No, client look same thing. Monitor icon. No, man.
It's just below the face.
Client. No, but file.
Nó ao như vậy em thêm nữa bộ khăn có việc chọn đừng nhà thấy nó cái lô trên file rồi
Okay. Please wait a bit. Coming soon. Download.
The left side of your screen,
Okay.
you can see the cloud, face, and the monitor. Just click the monitor.
I'll click like monitor. It's not one. It's different from our.
Good morning, ladies. Good morning, ladies and gentlemen. My name is Ashish
We are
Sharma.
on the session. Mr. Ashish Sharma, we are on the session.
No.
You-
We add already, but not up here.
Okay, then I will.
Okay, this one.
Yeah.
Yeah. Okay, we got it. Tất đã ao thông đã slide.
thì mới khơi ngõ này nó
Chẳng bỏ ao như nó PowerPoint này là
pointer
pointer là nông nghiệp.
I will manage that.
Ta này đã nó. Okay, please wait. Sorry for technique. Okay, now allow me to present. I have 15 minutes.
Yeah.
So how can I use this?
So just tell me. So next.
Oh, this is from the slide from you?
Yeah, it's from my side.
Oh, not from me. Rồi thôi, bà Kim miền này. Okay, so please use the slide from your side because I tried not allow. Yeah.
Yeah.
Okay, my presentation on the climate resilience in Cambodia. So I try to use the word how to enhance the transboundary climate resilience. I take case in Cambodia for the river 3S river basin. So now you can see the location of Cambodia in the Mekong River basin, comprised of 6 countries from China, Myanmar to Thailand, Laos, Vietnam, Cambodia, and Vietnam as the end, Mekong Delta. So this is the table. So the Mekong, Lam-Sang Mekong basin, where from the China, how the countries share, China, Myanmar, Latvia, Thailand, Cambodia, and Vietnam. And then for Cambodia on transboundary river basin that we share with Vietnam, with Laos, with Thailand. Next, please.
Yep.
This is the map, the Cambodian map. We divide of Cambodian river basin to 39 river basin, to the river basin and sub-river basin. So this is important to think about the water information in order to manage, to maintain the function of the river in the Cambodia. So we have worked close with the Mekong River Commission, and in the countries, at the country level, we are going to develop the data center very soon. So far, we don't have enough capacity for storage, for maintain and manage data in Cambodia, especially water resource data information. So we are going to develop this center, and we work with MRC and with another stakeholder at the grassroots level in some provinces also located in Cambodia. Next, please. And this table just show you about the Cambodian river catchment, those catchment in the map, like designed by the government for 39 river basin, but we have also catchment and sub-catchment in each river basin. Yeah. So the total area in the sub-catchment of the total area of Cambodia. So how about the climate change influence to Cambodia? Mostly come from the change of rain patterns. It means more rain, more flood. Less rain, that means less water, dry or water scarcity. So important, there are 4 areas of flood. Important Mekong flood, but the flood along the Mekong rivers, and then tributaries of the Mekong, we call that flood when the heavy rain coming, and then flood easy. This year, the flood, almost more than half country affected by flood, 2020. And then flood not only in the country, but in the city, So we call urban flooding. And then the failure of structure when the flood coming from the dam break, example, also flood. Yeah. So this is the map show you almost when during the wet season, located along the river, the middle country are flooded. You can see the picture are flood. And then right side, also the picture where around the Tonle Sap Lake, the flood coming and extend the area of the Tonle Sap to be flooded. Mainly in those years mentioned from 1978 up to mainly 2013, but for the 2020 also the high flood, like a flood because of heavy rain and storm water. And this is just the slide show you about uncertainty of climate change in the world, even in the Southeast Asia. Yeah. Now for this presentation, I take the case study for you, your consideration or information on 3S River. What is the 3S River? You can see the Cambodian and the yellow is the part of 3S River we share with Vietnam and with Laos PDR. So in Cambodia, 3S about 33% of the area in Cambodia. We are downstream, Vietnam Laos upstream. So again, this is about the hydromet station that show we are existing in the 3S, yeah, and 4P. So you cannot see. And this is from my study that I found that for the climate change scenario for the next 2040, it means that climate change coming, that happen in it. So the climate change will reduce the flow and will reduce the river flow and the discharge of the river. So they change from month to month. You may see that from May to October is the rainy season, and from the November to the April are the dry season. So you can see the down on the graph is the -1. So we may face the issue of the flow because not enough rain in the future. Yeah, in the future for 2040. So the station that I take as example really important to show us for the next 40 years, maybe 20 from now, will become more serious drought. So this I take example, we have the hydropower dam at the Saisan River basin in Cambodia. In Vietnam side, in Laos side, there are many dams there, but in Cambodia it's the first dam in Cambodia. So for the climate change, they will affect the dam in terms of water flow, in terms of the river flow and water flow. Not enough water, difficult to get the electricity from the dam. Yeah. So we think about how the dam will be affected by climate change. So on the next slide is about the Cambodia. We work with the different mechanisms like Mekong River Commission and Cambodian National Mekong Committee respond for the water river cooperation with other Mekong River basin management countries, and also Cambodia we work for the UNFCCC climate change also adopted by Tokyo protocol in 22. This is important document that we work for climate change resilience, and we, in order to take consideration on climate change resilience and adaptation, we work with the whole Mekong Lanshan country, including China and Myanmar. Just start working since 2015, and recently in last 2 years, we signed the 5-year agreement among the Lanshan Mekong country that address also climate change there. And this also about the climate change that we need to think about what the climate affected to the revenue of the country. So important event like when drought, when much flood, so impact to the socio-economic as well as environment. So like Yunnan presented already, the vulnerability in any aspect of the climate change apply for every country in the world. So in Cambodia.
과장님 죄송한데 저희가 다음 세션을 준비해야 돼서 저는 나가봐야 될 것 같습니다.
During the drought, we have the wildfire in Cambodia, and during the flood also we have bank erosion, we have flash flood like I said, and we have So we can find a way how to adapt and mitigate the climate change. Important how to understand well about the climate change in the international, national and regional aspect, especially Cambodia. So the people may think about this important to support the country adapt the climate change and mitigation. And however, people can confuse a bit about the conceptual of the climate change. Sometimes flood, sometimes not flood. You know, people said it is the normal, but it's normal. It's from climate change. So adaptation measures should be example, generate electricity, in particular how to save.
Vadim. Well, the Vadim, just turn on the mic. Vadim, please turn on your mic. I'll call Vadim.
Can you hear me?
Oh yeah, Vadim, please turn on your mic. You just turn off the mic from the other side. Please turn on your mic. Vadim, can you hear me? Hi, speakers, participant. I think Vadim Sokolov has some technical issue about internet link. So it's a pity for us. We couldn't access to Vadim again. So anyway, thank you so much for your whole presentations and the speeches. So, well, first of all, I'd like the express many thanks to Yuna. It was a great the explanation and the introduction and the voice from outbox of the conventional water sector. So just to explain about the vulnerability and the exposure for the climate vulnerability from for the gender aspect. So it was very interesting for us to understand that the socio-economic aspect of the climate vulnerability. Vadim, you can say now. Vadim, can you hear me? Hi, Vadim.
Maybe internet slowly.
Okay.
It's slow internet.
Actually, he waited more than 1 hour. Just in front of the his the smartphone during the the field survey outside of Tashkent. Actually, he already sent me his presentation file, so I was going to upload his file, and he was going to make a speech about that. But I think the link is not smooth. Okay, I'm sorry. I'm very sorry, Dr. Vadim, for not smooth connecting the internet. So also, I would like to appreciate Yuna for the some socioeconomic dimension of the climate vulnerability. It can be incorporated in the governance, culture, and knowledge. So the climate inequality and the climate justice was very new for me. So it's kind of some new agenda for the conventional water box. And also the presentation from Mr. Nobel Balija. So he provided a very comprehensive introduction of current Korea smart water grid system experiences with a very high technology. And also thank you for the very nice definition of smart water grid. Also the concept, including the benefit from the smart water grid. So he already showed that he also showed some case study of Nepal, the Beni municipality. The population is about 33,000. It was and he already showed potential revenue when applied that kind of smart water technology to the Beni city. Also, the mobile water treatment unit was very impressive. It can be installed in truck or the container box for the remote area, village, and it's just for some decentralization of the water supply. So, and also that the presentation from His Excellency Mr. Wat Kosa, it was very comprehensive explanation about flood issue and some institutional issue in Cambodia for flood management. Also, I really appreciate your very the in-depth explanations about the serious river basin flood management issue. Thank you so much about that. So the speakers, can you guys, if you guys agree, I'd like to share all the speeches, your presentation files, the PDF version to all the speakers for the more understanding. If you agree.
Yes, I'll send you the file.
So you agree to share your file to
Yes,
the speakers.
I will send you
Okay,
the
thank you. And Bokosa, I would like to share your presentation with Dr. Vadim and Yuna.
Yes.
Thank you so much. Hi, Sokolov, so we can communicate later. Thank you so much your contributions. Thank you very much.
Thank you. Yeah. Okay, see you next time. Yeah, Dr. Hong.
Bye.
Thank you, everyone, and see you next time.
Thank you. Vatana, យើងអាចបិទបានវត្តណាបិទវត្តណាបិទចប់ហើយ Dr. Hong,
Yeah.
You received my email?
Not yet, actually.
I sent you already. Yeah.
Yeah, I'll check it.
About CDC.
Please stay there. Oh, you mean that the communication with the CDC?
Yes.
Okay, I saw that.
Yes.
Actually, as I explained in the today meeting, the process is totally different. So as the CDC mentioned, she mentioned the proposal for 2022 is already closed.
Yes.
So this is additional fast track for 2022. So it's a kind of some extra project.
Yes.
Extra gift.
Yes. Could you write? I will consult with CDC. If
Yeah.
you write about that, I will bring your message and
Okay.
talk to CDC.
Okay.
On Monday.
Okay.
Yeah.
Yeah.
Because she did not aware about that.
Exactly.
But
Yeah. It's the
he
first
said-
time.
Yes, he said that if we have any information more from your side, it's
Okay.
very much appreciated and useful.
Okay. Understand that. I will send that. I will send that. Yeah.
Yes.
Okay. Bye.
Please, thank you very much.
Thank you very much.
Yeah, thank you. Yes, thank you. What